Divisibility, what do you mean by divisibility? Can someone explain like what do we mean by divisibility? Hello, Ruba, can you explain that?
Sir, I think it is based on a number divisible by another number.
Yeah, matlab like divisibility is ability to divide or if a number x is given, will it get divided by 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or similarly other numbers? So can we decide if a big number x is there, like 234 is there? So how we can say or what can we predict that it will be divisible by 2 or 3 or 4 or 5 or 6 or 7? And if 234 is still a lesser number, or less number, like a number which is very small, if a big number like 2, 5, 8, 9, 6, will this number get divided by 8? And a test of this for every number is the basis of this chapter. So to start with, we will start with the obvious primes or obvious numbers, or not obvious, but like smaller numbers, and then we can expand it to bigger number or other numbers also. So the first of all, let's see that how a number gets formed, like how we make a number in our decimal system. So I have also explained this in our previous classes that we use a decimal system, which is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So these after these 9 digits, counting 9, we write 10. This says that one time tens has been achieved. So 10 has been achieved or counted. So that's why we call it a decimal system. So then, if you want to count again, you'll write 1 1. Like after 110, you have one extra. Then 1 2. It says after 110, you have two extra. Then 1 3, and similarly 1 9, and then 2 0, which says 210 has been counted. And then when you write 2 1, it is like 210, and similarly 2 9, like 210 and 9, and then you have 310. And if you go likewise, and finally you'll get like 9 10 and 9, 9 10 and 9, and after that we'll see that 10 times 10 completed. So this 10 says 10 times 10 completed. So this is how we do write our or count in our decimal system. So I have already explained that once we write 500, this what does this mean? That 5 times 100 has been completed, and then other is 0. And if the number is 593, this says 5 times 100 has been completed, then 9 times 10 has been completed. This place is for 100, this place is for 10, and this is unit, and 3 is alone. So this is how we can expand the number to realize how much is this. And we have already told you that 5 is a digit which face value is 5. Face value is 5 only, and place value is, how much is the place value here for 5? It is 500. So now you know this thing, and with this background, I'll be explaining or I'll be devising the divisibility rule for different numbers. Okay. So uh, the first number for which we will devise a divisibility rule will be 2 only. So what do we know about 2 is, And why did I explain the entire thing here? That this 10, 20, 30, 40, it's a pattern. Like every time when you move 10 to 20, you'll be going ahead 10. And 20 to 30, you'll be moving ahead with 10. And similarly, 100 to 200, you will be moving ahead 100. So this pattern is important to devise the divisibility rule. So now when we were talking about the divisibility of 2, the simple idea is to check if whether 2 is dividing the base pattern or not. So what did we see, or what we can see is that the 2, like 1, 2, 3, 4, 5, 6, 7, 8, and 9 and 10. So 2 divides 2 itself, and then the next 2 will divide 4, the next 2 will divide 6, 8, and then 10. So what do we see here? 10 is being divided by 2. So the 10 extra, when we'll reach 20, it will also get divided by 2. 10 extra, 30, which will 10 extra from 20, it will also get divided by 2. And similarly, 100 will also get divided by 2. So once 100 will get divided by 2, 200 will also get divided by 2. And similarly, 1000 will also get divided by 2. Then 2000 will also get divided by 2. So the point is, so once the 10th digit, the last digit is 0. So like if 2, 5, 3, 4, and 0. So this is what, this number is what? These times 10. Like the entire number can be broken into 2, 5, 3, 4 into 10. So how many times 10 is there? These much time of 10 is there. If 10 is divisible by 2, so the entire number will get divisible by 2. So with this logic, what do we see? So once we have achieved 0 here, and not achieved, we have got 0 here and it get divided by 2, then plus 2, plus 4, plus 6, plus 8 will also get divided by 2. So what do we see now? After this and this, 42, 10 ahead 50. In between these, 2, 5, 3, 4, 2, 2, 5, 3, 4, 4, 2, 5, 3, 4, 6, and 2, 5, 3, 4, 8. All these number will get divided by 2. So in we can summarize this in a way. If unit digit is 0, 2, 4, 6, 8. Any digit is even, or these numbers, the number will get divided by 2. N, for which we are talking, and n is divisible by 2. So how many of you will say that I've overextended the concept here? Now let me pause the recording for a while. So the advantage of this explanation you will get for other multiple powers of 2. Like now after this explanation, if you want to find the divisibility rule 4, not of divisibility rule 4, 2 to the power 2, which is 4, 2 to the power 3, which is 8, 2 to the power 4, which is 16, and similarly. So all these, for all these numbers, now divisibility rule will be very simple. Like what we can easily see here is that when we write down the number like 4, 8, 12, all these numbers are divisible by 4. And finally, what we see that 100 gets divisible by, or 100 gets divided by 4. So it's a divisible by 4. So now every 100, like when you move ahead in 100 terms, so everywhere it is 100 extra. So next 100 will also get divided by 4. So all the hundreds will get divided by. So even when we say 10,000, like 10,100. So we are moving 100 in term of 100 only. So even this will get divided by 4. So what we can say that any number like we have 2, 5, 4, 3, 6. If I have this number, I will divide into two parts, 25400. Like how we can break this number, 254 hundreds plus 36. So I know due to this explanation, this number will always get divided by 4. We just need to check this one, last 2 digit. So the divisibility rule for 4 would be check the last 2 digit. Check the last 2 digit. Okay, digits. So this is how we explained the divisibility rule of 4, which you have been studying since your class 6 or 7, but nobody have nobody might have explained it to you. So now let's go for the divisibility of 8. So similarly, when you go ahead with the numbers divisible by 8, 8, 16, and more, you will see that 1000 is divided by 8. Divisible by 8. So all the number who is moving ahead with thousands difference, every number will get divisible by 8. So 2000, 3000, and any 1000 will get divided by x. So now again, if a number like 7, 8, 9, 2, 3, 6, if this is a number, I'll break this number into two terms, 7, 8, 9, 000. Like this number is 789 thousands, and 236. I'll break 236 different separately. So I know this number is divisible by 8. We just need to check this one, whether it gets divided by 8 or not. So if it gets divided by 8, then it is divisible by 8. And whatever the remainder you are getting here will be the remainder if the entire number will get divided by 8. So with divisibility rule, actually you can also find the remainder. So if someday, if there is a question like, if a question comes at like 2, 8, 9, 7, 2, 9, 3, 5, 4, 3, 8, 9, 6. So if this is a question, no, not 9, 7. So if this is a question and someone's asked you if it is divided by 8, what will be the remainder? So you know that this number can be break into this much of 1000. So all these will get divided by 8. So the remainder that we'll be getting is from 897 only. So whatever the remainder you will get here will be the remainder for the entire number. Okay. So similarly, when you go for 16, 16 divides 10,000. 16 divides 10,000. So when you go for 16, 32, and if you go ahead, it will divide 10,000. So with this 10,000, we can devise a divisibility rule for 16, which will say that if the last 4 digit is divided by 16, the number will be divisible by 16 only, like 2, 3, 5, 8, 9, 6, 7, 2. If this is the number, then you know it will be breaked as 2, 3, 5, 8, 8, and this much of zeros, and plus 9, 6, 7, 2. If 16 divides this, the number is divisible by that, or whatever the remainder you are getting here will be the remainder when this number gets divided by 16. So many of the time they might ask, divide it and find the remainder. So in that case, you don't have to actually divide it. You just have to divide the last 4 digits of that number to find the remainder. Then it gets divided by 16. So similarly, you can devise the 2 to the power 5, 32 divisibility rule for 32 also. So this is the rationale behind the divisibility rule of 2 and all the power of 2. Okay. Now the next number I'll be taking here is 3. The next number I'll be taking here is 3. So when a number gets divided by 3. So one simple explanation which everybody knows is if the digits, if the sum of the digit, if sum of the digit, no, sum of the digits, of course, sum of the digits of the numbers of the number gets divided by 3, it will be divided by 3 1. So this is the divisibility rule of 3. So now let's explain it also. We are checking about 534. We need to check whether this number is divisible by 3 or not. So let's go to the decimal system only. What we know, the first 10 we get here is 10. And similarly, we get 20, 30, and till 90. Then we get 100. So we get then 200, 300, and similarly 900. Then we get 1000. So here we get 2000 and till 9000 and so on. Then we can get 10,000. Then we can get 20,000 and so on. So what if 10 gets divided by 3? So you'll get a remainder of 1. Yeah? You get a remainder of 1. If 20 divided by 3, you'll get remainder of 2. If 30 gets divided by 3, you will get remainder 0. Because 1, 2, 0, 1, 2, 0. But for the sake of finding a rule for divisibility, I will consider here the remainder as 3. Yeah, let's consider that remainder is 3. And you know by your heart or underneath, whenever the remainder is 3, the number will get divided by 3. So we'll put all the, if 40 gets divided by 3, I'll say the remainder is 4. Just for the sake of making a formula, making a trick for divisibility, I kept this remainder because this is not the remainder when something gets divided by 3. So remainder can only be either 1 or 2 or 0. So but we kept this, and similarly, when 90 gets divided by 3, we'll keep remainder as 9. Similarly, when 100 gets divided by 3, we will keep remainder 1. When 200 will get divided by 3, we'll keep remainder 2. And when 500 gets divided by 3, we'll keep remainder 5, and so on. We'll be making such assumption that these are the remainder when these figures are getting divided by 3. So now, for 534, what I am saying here is it is 500 plus 30 plus 4. And if it gets divided by 3, here I'll be getting remainder as 5, here I'll be getting remainder as 3, and this 4 is, let's take this 4 as it is. So now the total remainder is this. Rest everything gets divided by 3. So the total remainder that I'm now having is 5 plus 3 plus 4, which is 12. And if this 12 gets divided by 3, the entire number will get divided by 3. So did you understand what I did here? So let's take another number, 7, 8, 9, 2, 5. Let's say if this number is there. So now we want to check whether it number get divided by 3 or not. So I'll convert this number as 40 plus 30, 920 and 5. And if you divide all these numbers by 3, I'll be getting 7 remainder here, 8 remainder here, 9 remainder here, 2 remainder here, and this 5 as it is. So the total remainder I'm getting 7 plus 8, 15, 15 plus 9, 24, 24 plus 2, 26, and 26 plus 5, 31. So now this 31 doesn't get divided by 3, it leaves a remainder 1. So even this number will not get divided by 3 and leave a remainder 1. Okay, is it clear to everyone?
Yes, sir.
So the same thing will do for 9. So if you want to find out that whether a particular number gets divided by 9 or not, we'll be following the same logic. What I'll do, I'll keep 9 here and let's change the entire board to 9. The concept is same, which was here for 3, and so if 9 divides 10, you get the remainder 1. If 20 gets divided by 9, you get remainder 2. 30 gets divided by 9, you get remainder 3, and for 40 we get 4. For 90, it is ideally 0, but let's keep 9 as a remainder. Similarly, for all these cases, if divided by 9, we get 1. If 400 gets divided by 9, we get 2. And this and we will follow the same for all the other digits. So if there is a number 7, 8, 9, 2, 5, 6, not 8. So if this is a number, so we'll break the number as like this. And I know that if these numbers gets divided by 9, here I'll get the remainder 7, here I'll get the remainder 8, here I'll get the 9, here I'll get the 2, here 5 and 8 itself. So I'll add all these 7 plus 8, 15, 15 plus 9, 24, 24 plus 2, 26, 26 plus 5, 31, 31 plus 8, 39. So if 39 doesn't get divided by 9, the number will not get divided by 9, or whatever the remainder you will be getting here, like remainder is 3. So if this number gets divided by 9, you will also get the remainder 3. So with divisibility rule, you can also find the remainders which can be which you can find after the division. So is it clear to everyone?
Sir,
Tell me.
हेलो
सुन रहा हूँ मैं, बताओ. Tell me.
सर ये मतलब बेसिकली हम लोग यही कर रहे हैं ना कि
Okay, so for 5, it's quite clear to everyone that like for 5 also, 5 and 10, it's get divided by 5. So every number which has a 0 at the end will get divided by 5. Same logic as we put it for 2. And also in between, if there is a 5 at the last point, the last digit, then this number will also get divided by 5. So for 5, it's very simple, like 2, 5, 8, 9, 5. If this is the number, we'll divide it like 2, 5, 8, 9, 0 plus 5. This also get divided by 5. This also gets divided by 5. So entire number will get divided by 5. So it's quite easy for 5. Now let's go for 7. And it'll be, next I'll be explaining divisibility rule for 7, 11 and 13. So for 11, we will have 2 different divisibility rule. For 7, 11 and 13, we'll make one rule here. And this rule is
Sir,
rely. Yes, tell me.
सर मैं 5 का ना मिस कर गई तो वो कनेक्शन की वजह से, और एक बार दिखाइएगा क्या?
5 is like 5 and 10. So 5 also gets divided by 10. 5 and 10 also gets divided by 5. So with this, we see that every number which has 0 will gets divided by 5. And in between number after 10 and 20, if there is 5 more than 10, it will also get divided by 5. So what we did here is we made a rule like 28950. It will also get divided by 5. 289,565. So this number can be broken into 289,560 plus 5. So it's also get divided by 5 and this one also. So this number also gets divided by 5. So the ultimately the rule comes down to if the unit digit is 0 or 5, the number will get divided by 5. Okay.
Yes, sir.
Okay. So now we'll be explaining divisibility rule for 7, 11 and 13. And the rationale behind this is if we multiply 7 into 11 into 13, we'll get number what? Someone tell me. क्या मिलेगा हमको यहाँ पे? What will I get if I multiply 7 into 11 into 13? क्या मिलेगा? So we get 1001 here, and this is very close to 1000, and calculation related to this number will be quite easy. Like if a number, single digit number like 5, if you multiply 1001 with 5, we'll get a number 5005. So since this gets divided by 7, 11 and 13, this will also get divided by 7, 11 and 13. So if like any other unit digit, like a digit, if 8 gets multiplied by 1001, I'll be getting 8008, and this number gets divided by 7, 11 and 13. So we cannot directly check a number through this rule, whether it's get divided by 7, 11 and 13, but we can break the number into two parts. Like, let's say if somebody asking me whether this number gets divided by 7 or not. So what I'll do here, I'll break this number as 8008, which is this, plus 17. So now what we know is that this gets divided by 7. This doesn't get divided by 7. So this number will not get divided by 7. Okay. And the remainder that we'll get here will be the remainder of this division also. So what we see here is that remainder is 3 here. So after this division, we'll also get 3 as remainder. So for any number, we'll break into similar way, similar fashion. So if a single digit gets multiplied, like if you multiply 1001 by 9, you will be getting 9,009. This way. If two-digit numbers gets multiplied by 1001, like if a number is like AB into 1001, you'll always get a number AB0AB. Like how we are getting it. So if 13 multiplies 1001, 13, let's take 19. There is no problem with 13, but 13 already gets divided by 13. So if 19 gets multiplied by 1001, we will get 19019. So now we know that this number will get divided by 7, 11 and 13, all these numbers. So similarly, if we multiply a 3-digit number like ABC with 1001, you will be getting ABC, ABC. So this particular thing which I am writing here, this one, and of course this one, that if A multiplies 1001, this 3 things will always help you in other questions also. So in what way you will see later, but for divisibility itself, okay. So now we can say that if I have a number 728 900, not 900, 90912. Let's say this is the number. And if someone wants to know that whether this number gets divided by 7 or not. So what I'll do here is I'll break this number as 728 and 728. And I'll find the difference here from this number. So the difference would be 72 plus 112. 72 plus 112, it will be 184. So now we can easily check that whether I know that this number gets divided by 7, 11, and 13. So we just need to check whether this number gets divided by 7, 11, or 13 or not. So if it's get divided by 7, 11, and 13, then the entire number will get divided by 7, 11, 13. And whatever the remainder that we'll be getting, that will be the remainder of actual division. So is it clear to everyone?
Sir,
Mhm.
sir,
Tell me.
सर मतलब ये जो कोई नंबर ऐसा आएगा तो अगर वो 7 से डिविजिबल होगा तो 13 और 11 से भी होगा क्या? ऐसा है
नहीं
क्या?
नहीं नहीं, बिल्कुल नहीं, बिल्कुल नहीं. Okay. So मतलब sometimes you get confused in that also. Let's say I am writing a number 700 7035. Okay. So let's say this is the number, or 803. Let's say 8036. Okay. So let's say we want to check that whether this number divisible by 7, 11, or 13 or not. So you know that I'll break this number into what? 8008 plus, how much is left? 28. Now I know that this number is divisible by all 7, 11, and 13. But this number is only divisible by 7. So 8036 can only get divided by 7, but not by 11 and 13. Are you getting my point?
Yes, sir.
So it will depend on the part which is extra from the these numbers.
Number. Okay.
So whatever the
Okay.
extra is there, you can check with that whether that number is divisible by 7, 11, or 13, or maybe with 2 of them, or maybe with all 3 of them, or none of them, or any one of them. Okay.
Okay. Sir, one more question. If like we have to find any number, it is divisible by 11, 7, or 13. So first we have to break this number into this format, like this one, A into 1001 into this format.
Like either
Then we can check.
into this format or this format or this format. So probably
Okay.
you will not get any number which is bigger than that. But most of the time you'll having mostly 6-digit number, and you can easily divide that number into these two parts. So like sometimes what will happen, sometimes you will get the less number, if somebody is asking you to get the divisibility 528 356. So if someone is asking that find the divisibility of
13.
let's say 13. So what I'll do is I'll change 5 to 8 and 5 to 8. But what we did take is extra, is more than this. So how much is more? I'll write that. This number is this minus something. So how much is the 44 and 100, 144 and 28. So it is like 172. So it is 172 extra. So now if we'll divide this, it get divided by 13, but it doesn't get divided by 13 if, okay? So this number will not get divided by 10.
Okay. Got
Okay.
your point, sir.
Or second, what you could have done is you could have changed, you could have made it like this: 356, 356 plus, and you could have find the difference here: 356 and 528. It will be 172,000. Okay.
Yes, sir.
So
Means we have to break into ABC format.
ABC, ABC. So what we can see here is if we check 7, so this number gets divided by 7, and this also gets divided by 7. No. अगर यहाँ पे एक और ले लेते ना, let's say, so this doesn't get, if you have 182 here, now let's say, then it will get divided by 7. Okay. So by similar way, you can find the divisibility of all the numbers by breaking into these 3 type of numbers. So A00A, AB0AB, and ABCABs. You know? So
yes, sir.
all these numbers which are in this format will always get divided by 7, 11, and 13. Okay.
Okay.
Okay. So there is a different rule for 11 also. Is also very interesting to know.
Prime numbers or prime digit or
Not prime digit, odd ones and even ones. Like for 11, I'm talking about.
Okay.
So if any number is there, let's say if a bigger number is there, it's a second rule for divisibility for 11. So if a number is there like 729285092, like this number is there, and someone asks you whether this number gets divided by 11 or not. So in this case, you can take from either side, better to take from this side only. Take all the odd places like 1, this, all these odd places, digits of all these places, and add them. So it will be 7 plus 9 plus 8 plus 0 plus 2. And then take all the even places digits and add them. 2 plus 2 plus 5 plus 9. And add all these like 7 plus 9, 15, 15 plus 8, 23, 23 plus 2, 25. And this will be 2 plus 2, 4, 4 plus 5, 9, 9 and 18. So if we'll minus 1 from the second, if it is either 0 or multiple of 11, then this entire number will get divided by 11. Okay. So let's change the number a bit. Let's change the number here by 5. So let's change the number here by 5. So let's write down the number again. Not the number. The numbers at the even places, like odd places and the even places. Now the sum of the digits of the even places will be 2 plus 2 plus 5 plus 5. So it is again, it will be 28. 9 plus 7, 16, 16 plus 8, 24. 16, 16 plus 8, 24, 24 plus 2. Oh. So the previous one was quite fine. So whatever, but there was the calculation mistake. So if we'll keep this number here, previous one. So what we see here is 7 plus 9, 15. No, it was right. Okay, it was fine. So if we'll change the number 5 here, this number will be 5 and this will be 14. Okay. And what do we find here is the difference is 11, which is of course multiple of 11. So now this number will get divided by 729285052. You can check it by dividing it by calculator. That's this number will get divided by 11. So this is the another rule for 11, that if all the unit places, all the even places number digits, even places minus odd places or whatever, you can change this. So either it comes 0, 11, 22, minus 11, minus 22, minus 33, 33. So whatever the difference you get here, it will get divided by 11. And if you are not getting these, so this number will not get divided by 11. Is it okay for everyone?
Yes, sir.
Okay. So now we'll go for the number which are composite numbers. Like let's say we want to know whether the number is divided by whether the number gets divided by 6. How, when a number will get divided by 6. So such number will be broken into two co-primes. Like here, it is obviously the only two factor which is there for 6 is 2 and 3, and which are co-prime in nature, which are already co-prime in nature. So if any number n which separately gets divided by 2 and separately gets divided by 3, so it will also gets divided by 6. So similarly, if you want to check that whether a number gets divided by 36 or not, so what we need to check here is we will break the number into two terms, 9 into 4, which is co-prime, and you will break the number in only those numbers for which you know the divisibility rule. So it's a co-prime number, and co-prime it together. So if that number n gets divided by 9 also, which you can check through the divisibility rule, and if that number also gets divided by 4 and separately, then that number will also get divided by 36. So tell me that how we can check the divisibility for 21 or
3 or
28.
7.
Exactly. So we know the divisibility rule of 7, we know the divisibility of 3. Similarly, we know the divisibility rule of 7 and 4. So if that number separately gets divided by 7, separately gets divided by 3, then the number will also get divided by 20. So this is how we can break the composite number into two different numbers, and we can check, or even into three different numbers. So if someone, all of a sudden someone asks that, check what will be the divisibility rule of 42. So again, it is 7
237.
into 3. Yes. So we know the divisibility rule for all these three numbers. So if the number gets divided by all of these three separately, it will also get divided by 42. Okay.
Yes, sir.
So this is all for the divisibility. We will not be going ahead with what was the second objective of today's class? Can someone remind me?